to solve this question here, which is the series circuit. We know this is series because they're all connected in one loop right here, and I'm going to show you how to calculate this. So the first step we got to do this is find the resistance equivalence, the REQ. So resistance equivalence of this circuit would be the sum of all the resistors, so 17 ohms plus 12 ohms plus 11 ohms. And we find that when you add that together, that's 38 ohms. We basically need to do this because we're basically reducing this down into a single resistor, like this, which is 38 ohms, as you can see here. And this is right now measured as 60 volts. So that's step one. Step two is to find the total current by taking our voltage and dividing it by our REQ. So in this case, our voltage is 60 volts divided by 38 ohms. So if we do that, 60 divided by 38, I'm around that, 1.58 amps. Okay. So in this circuit, since it's 1.5 amps, it's the same, series I is the same, so the current through each of those resistors is all the same. 1.5 amps, 1.5 amps, 1.5 amps. So now what I'm going to do, I'm going to clear the screen, is I'll solve for the, let's do it like this. I think I could do this. And then the fill would be solid, and we'll go, oops, like that. Just doing that, and then I'm going to do the same thing here. I'm just going to clear this screen. There we go. Good enough. I'm not doing a good job of erasing this. There we go. There we go. It's a lot better. There we go. Alright. So what did we find? Right now we found that the REQ was 38 ohms. And then our I total is 1.58 amps. And like I said, this is the same throughout the circuit. That's because we're in a series circuit. So it doesn't matter. So I1 right here is 1.58 amps. That's because we have one series. So now basically we got to find the voltage across each of these. So to do that, I'm going to take my current and multiply by the resistance for each one. So 1.5 amps times 17 ohms for the first one. The second one will be the same, 1.5 amps times my resistance 2, which is 12 ohms. And V3 will be 1.5 amps times 11 ohms, like that. So let's go ahead and calculate these. I'm going to do it on my calculator. Let's see. There we go. Calculator. 1.58 times 17. This gives me 26.86 volts. 1.58 times 12. 18.96 volts, and then this is 1.58 times 11 ohms, so 17.38 volts. Sorry, I'm squishing it in here. So the point is, I'm using Ohm's law. This is I equals V equals IR is another form of Ohm's law, which is this rendition right here. So the voltages should add up to 60 volts. It's kind of like a check. So 26, 18, and this. I'm going to do that really quick. 17.38 plus 18.96 plus 26.86. I get 63.2. So it's a little higher. I probably was rounding a little weird, but you can see that these two roughly match right here. So in a series circuit, remember that our I is the same, and then our voltage is split. And that's what we calculated here for our series. So notice I didn't like do all three currents just because they were the same value. So this is how you can solve all of the components, the voltage and the current for each component of a series circuit.